So types of feedback. We have two types of feedback depending on the circuit. We have positive feedback and negative feedback. So in positive feedback, the mixing is going to be additive. I'm going to add the feedback signal with my source. So the feedback signal, you know, it is VF and the input signal is VS. So the net signal will be VI equal to VS plus VF. So in the mixing side, the signals are going to be additive, or I can say both the signals are in phase. Only when the signals are in phase, we will add. The signals are out of phase, we will subtract, right? So Vs and Vf are going to be in phase, so it is going to be additive in the input side. So you can see when you add two quantities, the value of Vi is going to be increased. So when Vi is going to increase, V naught is also going to increase. So this will lead to the output voltage increasing exponentially because VI is constantly increasing. Therefore, the amplifier will increase when the input to the amplifier is going to be larger. The output is also increased proportionately. So V naught would also increase exponentially. So in this amplifier, the output voltage keeps on increasing exponentially. So this type of feedback is called as positive feedback or regenerative feedback. Positive because the signals are additive, regenerative because the output voltage is growing exponentially. So that is the reason why it is called as positive feedback or regenerative feedback. Now we are going to find the gain of the amplifier with feedback. So you know, right, the expression for the AF is equal to V naught by Vs. You know, whenever you are going to consider the feedback, you have to consider the source voltage or source current. So here it is V naught by Vs. From this equation, see, you know Vi equal to this equation Vi equal to Vs plus Vf. From this you find Vs equal to Vi minus Vf. So if you rearrange the terms, I can find Vs equal to Vi minus Vf. So I am just substituted that in the denominator. So V naught by Vi minus Vf. Now divide the numerator and denominator by V naught. So divide the numerator and denominator by V naught. So numerator you see V naught by V naught will be 1. Denominator you see Vi by V naught is 1 by A minus Vf by V naught is beta. So if you take LCM for this, if you simplify the fraction and write it as a proper fraction of the form x by y or p by q, you will get the answer as A by 1 minus A beta. Okay, so till this AF is V naught by Vs, and what is Vs? From for the positive feedback, Vs equal to Vi minus Vf. Then I don't want all these voltages. I want to write everything in terms of A and beta. So divide the numerator and denominator by V naught. So numerator is already V naught. So V naught by V naught will become 1. Denominator is Vi by V naught is 1 by gain. A is V naught by Vi. So Vi by V naught is going to be 1 by A minus Vf by V naught is going to be beta. So if you simplify, you get AF is equal to A by 1 minus A beta. So this is the gain of the amplifier with feedback. Without feedback, the gain is simply A. With feedback, the amplifier is A by 1 minus A beta. So here, whenever you have a subtraction term in the denominator, it means that the value of AF is very high. You know, whenever you have subtraction, denominator value is very, very small, right? When denominator value is very, very small, this AF value is going to be very, very large. So in positive feedback,